Greetings, coders. In this video, we are going to talk about some common commands in the Linux environment. The first one is ls, or list. What list does is it lists the files and directories within either the current directory or a provided directory. In Bash that we'll use, there's also a well-known shortcut that's built into that called ll, which is two lowercase l's. And it does this command ls-la. And that will gives us additional information in the directory. So if we just do ls, we get just two of the file names. But if we do ls-la, we get this more detailed file listing that tells us information about that. One of them, data, was a directory. We didn't see that up here. And also tells us about the file permissions. And then we have we can use ll, and that does the same thing, where it gives us all the additional information and lists one file or directory per line. Point out again that we've talked about this some, but this is a program argument, and it tells ls to give that additional information. It just is providing the directory to ll is a program argument. ls wrote to standard output, so this is coming back to our terminal screen. It's standard out. In Bash, there are some simple ways that we can match multiple file names or directory names at once. And to do this, the most common way is the star wildcard, and that will match any number of characters. So ls star would list all the files in the directory. ls star.c would list all the files that end in C. There's also the question mark wildcard for a single character. So if we did ls file question mark.c, it would list file 1.c, file 2.c, file 3.c, etc. All of these are converted as soon as the user hits enter. So when you hit enter here, all of this file question mark is replaced with file 1, file 2, file 3 before ls is called. The next command we're going to look at is make directory, or mkdir. To make a directory, you just do mkdir and the name of the directory that you want to create. And then you can see using ll that we have now beep, that's a directory in there. Next command we're going to look at is move, mv for short. Move a file or a directory from the source to the target. So let's look at an example. If we wanted to move the file name config.xml to data, that's what this would do. This would move it, meaning that it would remove the current config.xml in the current directory and place it into data. So if we did a move beep into data/beep and then did an ll data, we would see that there's our file config.xml that we moved, and there is the directory beep that we moved. So the main thing to remember is that it goes from source to target. We can also use move to rename a file or a directory. So if we did move data/config.xml to data/me.xml and then listed, we can see that it's now renamed to me.xml. There is no, we don't see config.xml anywhere in the directory listing. The next command is cp, or copy. And it works exactly like move does, except, or similar to the way move does, except it does not delete the file. It just makes a copy of the file and places it in the target location. So in this case, if we do data/me.xml and then do data me2.xml, we can see that there's a me.xml and then there's a me2.xml. rm removes file or directories. Now, this is an extremely dangerous command because there's no second chances here. When you remove something, and I have done this, every developer that's worked in Linux has done this, where they remove stuff or remove a file or a directory, and it's gone at that point. You have to be careful when you're using this command. Here's an example where we remove temp test.c. So we have rm/temp/test.c. Directory removal. To remove a directory, which includes all of its contents, we need to use the -r with it. It's required. And this recursively removes all the directories and subdirectories within that directory in a single command. This is even more dangerous than the other one, because if you did this from the wrong spot, you could remove things that you're not expecting. Be very careful when using it. -I is handy to use with remove. It'll prompt you for each file that you want to remove. Then that way you know exactly what's being removed. We can use the pattern matching that we talked about earlier, so star, and remove everything that is not a directory and does not start with a period, so any of the file names. And then we can actually do the same thing recursively. So this is -I is a program argument that we talked about to interactively remove it. And then notice here that remove then takes another argument that tells it the file to remove. And then it writes out the standard output asking you if you want to remove the file. And you can select yes or no. Next, we can check the return code by echoing $? And then we can do LL data to see what's left in there, what's happened. And all of these that this is highlighting are standard output. The echo command prints the values that are provided via the command line as a command line argument out to standard output. We will see how this is pretty handy when we use it, combine it with other capabilities such as redirection, so that we can pass in data into our program in a consistent way. In addition to echo, there's printf. Printf has some more advanced features, but one of the key things to remember about it is unlike echo, it needs the string to be in quotes. And by default, it does not include a new line at the end, where echo does include a new line at the end. So let's look at this example. We use printf and it prints out, hi there people, no new line. And we can see that no new line afterward, the prompt just comes right up. However, if we do use a new line at the end, it prints out something that looks more like this. Cat. Cat prints the contents of a file to the terminal. It prints it to standard output. So if you give it a file name like this as a command line argument, it will then print out the output and output it to standard output. grep is another command that is similar to cat, except you're able to filter out what it returns based on a pattern that you give it. And so to use it, it looks something like grep, options, pattern, and then the file. This grep is a very handy tool in the command line environment when you're dealing with any kind of files or any kind of data. grep A, if we gave it the pattern A, it's going to return all the lines that have an A in it. If we gave it the file name animals.dat, it would say there were a ton of different animals here. It would return cat, alligator, cheetah, kangaroo, because all of these have an A in it somewhere. As I said, this is very handy. And we will talk about regular expressions in a later video. And you can actually use regular expressions in here too to get even more powerful pattern matching. And that's it for this video.